Hello, this is Shirley. In many businesses today, operations depend on availability of the organization's information systems. Ideally, we would like our system to work properly all the time and never fail. This is what we call a fault-tolerant system. In reality, however, we can expect that sometime something will go wrong. So what we want is to have a system that functions as planned in terms of speed, quality, and reliability most of the time. This is what we call a high availability system. An information system consists of several components. Any event that may slow the system, shut it down, or manipulate the output is considered a risk that must be dealt with. It is possible for the entire system to stop functioning even if one component stops working. Understanding what can go wrong and how it affects the business, if at all, is the first step in managing the risk and preparing for a recovery from a minor problem or a disaster. We need to remember that nothing works perfectly all the time. Think about your commute to work or school. Occasionally, you will be late. The reason might be a car that breaks down, a bus that is late, a lot of traffic on the road, or simply that you got up late. Similarly, we need to expect that even the best information system will not work perfectly forever. As time passes by, equipment gets older, the number of users grow, data gets more complex, and the nature of the business changes. Therefore, managing the life cycle of the various components of the system and refreshing them as needed is essential. Before we look at management of risk, let's focus on identifying risk, or actually asking ourselves, what can go wrong? Anything that may impact or interrupt the normal operations of an information system is considered a risk. The security industry is focusing on detecting and preventing intentional risk or malicious actions. However, it is important to remember that systems are exposed to unintentional risks like natural disaster or human error. On another dimension, we look if the source of the risk is internal or external to the organization. In general, we can reduce internal risk with proper planning and can only react to external risk. It is almost impossible to eliminate or even reduce the risk from external unintentional events. However, awareness and preparation can reduce the impact on such risk on operations. In this category, we count natural disasters like floods, hurricanes, and earthquakes, accidents like fire, explosions, human errors like damage to communication line by a construction worker, and failure of infrastructure like power, water, or telephone outage. Human error or equipment malfunction are two examples of internal unintentional risk. The risk of human errors can be reduced by redesigning processes, training, and the introduction of checks and balances. Equipment failure, on the other hand, cannot be prevented. However, companies can minimize the impact of such failure with proper management of capacity, life cycle management of equipment, backup units, and redundancy. Things become a little more complicated when you examine internal intentional risk. This is the risk of a disgruntled employee, contractor, or someone else with access to a system trying to stop it from working, corrupt or steal data, damage equipment, and so on. Regardless of the reason that motivates employees to steal from or sabotage the system, strict access control and monitoring can reduce the risk, while backup and recovery plans can minimize the impact on operations. External threats may be motivated by greed, ideology, revenge, political motives, trying to harm a competitor, or the simple pleasure of overcoming the challenge of breaking into a protected system. Regardless of the motivation, the deployment of security tools, monitoring, and setting security procedures provide some protection. In the event that a system is compromised, a recovery plan can minimize the damage and expedite the return to normal operations. So, what can be done about these threats? In the big picture, we need to consider each threat, eliminate or reduce it if possible, and be able to identify a problem and react when it occurs. The first step is physical protection. Limited access to company resources reduces the risk of theft and sabotage. Data can be stolen and software can be altered from a remote location. Therefore, logical protection needs to be in place. Measures such as a firewall, proxy servers, and access controls provide logical protection. Redundancy can be implemented at a single component or at a system level. For example, at a component level, installing two power suppliers in one computer or installing a secondary connection to a network increases availability. At the system level, a disaster recovery site can keep a company in business even if the entire data center is down. However, the degree of redundancy and the size of investment have to be justified. Smart procedures such as a systematic backup of data, adjustment of computing power and network capacity, and enforcement of password policy are examples of how right procedures can decrease the probability of risky events. Last but not least is monitoring of the system. For example, a slow response time might indicate a network problem, a capacity problem, or a denial of service attack. Unusual volume on the network might indicate hacker penetration or data theft. Establishing a baseline and understanding of normal operations lets us know whether things go wrong and raise red flags, which in turn can help us take action before the problem gets out of hand. To summarize, every information system is exposed to internal and external risks, either intentional or unintentional. Protecting the system is an ongoing process that involves constant monitoring, refresh of components and procedures, including employees' training and education, as well as periodical drills and testing the system's readiness. This is the perpetual return to the questions: what can go wrong, how can we prevent the incident, and what is the response if the incident occurs? Thank you.